Austin. All right, here we go. Last time with congruent triangles. All right, let's get started. So don't write this down again. Same thing that I've been putting up the past two videos. But today we are going to talk about HL. Okay. Now, write this slide down, please, please, please. A right triangle. So make a right triangle. You only need one of them. There's two of them on the slide. Only do one, all right, sir? Now we have to talk about the parts of a right triangle. There's specific parts of a right triangle. The key one being a right angle. Very important, a little right square in our triangle. The next one that's important is that we have legs. We have two legs for each right triangle, and these legs are connected to the right triangle. So anytime we have a right triangle, we're going to have two legs, and those legs are connected to the right angle. Okay? Now, what's really important is straight across from the right angle is the hypotenuse. All right, so you only need to have one of these, don't have both, so just have one of these written down, okay, sir? Just write one down. Parts of a right triangle, they're going to help us a lot with this shortcut that we have. If you know these shortcuts, you don't need to write this down, okay, sir? The hypotenuse is always across from the right angle. The hypotenuse is always the longest side of a right triangle. All right. Hypotenuse leg theorem. So write this down for me, please, sir. If the hypotenuse and a leg of a right triangle, this is really important, it has to be a right triangle, are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. All right, make sure you get this down. Push pause if you need. All right, now everything in yellow you need to write down too, please. This is our example. So there are two right angles. That's the first thing. You have to have two right angles in order to do hypotenuse leg. Next thing you need to know is that two segments are congruent. One leg, one hypotenuse. So BC is our hypotenuse, is congruent to EF. It's hard to see. And AB, which is a leg, is congruent to ED. Very important. So you need one hypotenuse, one leg, and a right angle. All right. None of these, Austin, do you have to write down, okay? We're just going to look at each one of these. This is our first example. If we look at this, can we decide if these are congruent triangles? Now, we'll think back to HL, hypotenuse leg. Most important thing is that it has to have a right angle. If we look at this one, it looks like it could be a right angle, but it doesn't have our symbol right here. So we only have two pieces of information. So this one is not congruent because there's no right triangle. All right, let's look at this one. All right, here. It means that side is also right because this is a straight line, adds up to 180. And then if we look at this one right here, this is reflexive. Remember, we have to write that down every time we see it. Reflexive property. Oops, PROP. Now, if we look at this one has a right angle, a hypotenuse, and a leg. So this one is going to be HL. Oh, I'm so sorry. I forgot to mention earlier, sir. Congruent statements, okay? Triangle RUT is congruent to triangle SUT. Okay, make sure you line up the angles that are congruent. So if we look at this one, R is congruent to S, U is congruent to U, and then T is both right angles, so they're the same. All right, moving on. If we look at this one, right now we only have two pieces of information, but if I add this right here, because of vertical angles, then we can say that these ones are congruent by angle, angle, side. And our congruent statement be triangle DEF is congruent to triangle JLF. All right, last one for this page. If we look at this one, we have a right angle, so HL is a possibility. We have a leg, and then we know that this one right here is congruent because of the reflexive property. Make sure we write that every time we use it. So we're going to use HL on this one. Triangle POM is congruent to triangle MNP. Alright, couple more examples to look at. We're just going to do 11, 12, and 13, okay? So 11, if we look at 11, we have 4 sides, and then this one can be also congruent because of reflexive. Make sure we write that, okay? Prop. And if we look at this, we have side, 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 so our shortcut's going to be side, side, side. Now, if we write a congruent statement, we can write triangle. I'm going to start here with V. VUT is congruent to triangle VWT. If we go to number 12, we can write this. We can write reflexive property. If we have the reflexive property, but if we look at this, we still only have 2 pieces of information for our triangles, so there's not enough information, so we're going to write not congruent. Alright, moving on to number 13. 13, here we go. We have lots of angles. So this one will be what? Angle, 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 but we know that this doesn't work, so we're going to write not congruent. Alright, you guys, I'm sorry, I changed my mind. I'm going to do one more. We're going to do number 14. Because I want to talk about 14 because we have a right angle. So first thing that comes to our mind, we're like, oh, HL is going to be used here. But we have to make sure we have a right angle, a leg, and a hypotenuse. If we look at this one, we have 2 legs. So this one's going to be side, angle, side. Alright, so make sure you check those. There's going to be a few like that on your assignment today and on your quiz. Alright. Now, this is going to be the last one we're going to go over. This will be on your quiz. We're going to have one of these. You've done them before. You do really well on them. But we're just going to make sure we know how to set this up. So I'm telling you that these are congruent. So then I have to set up 2 equations. X equals y plus 1, and my other equation is going to be x plus 3 equals 3y. Now, on your quiz and on our last test, remember you had to solve for a variable first. But if you look at this one, I already have x by itself, so I know x equals y plus 1, so I'm going to plug that in to my other equation for x. So I'm going to get y plus 1 plus 3 equals 3y. Combine like terms, I'm going to get y plus 4 equals 3y minus y, 4 equals 2y, divide by 2, so 2 equals y. Now I found y, now I need to find x, so when I know what y equals, I'm going to come over here, plug it in. X equals 2 plus 1, so x equals 3. Alright, that's all I have for you today, sir. I hope you're having a great day. Enjoy. Make sure you ask me or email me if you have any questions. Alright, bye.